So let's move on. We're going into problem solving, and this is an introduction section into problem solving. So let's look at this set of directions. It wants us to write an algebraic expression. So something you need to remember or even understand, maybe you've never understood this. An expression is different than an equation. So if I want to talk about an expression versus an equation, the big difference is this. An equation has an equal to sign. Expressions don't. Expressions do not have an equal to sign. An equation does. So in this particular case, they want us to write an expression, which means don't write anything with an equal to sign. Got it? Okay, so let's look at the first one. The first one is asking us to write the perimeter of a square. Well, you have to remember what the word perimeter means. What does perimeter mean? Yeah, it means add all the sides, right? The only geometric shape that doesn't have a side is a circle. And yes, you have to remember that formula. But everything else has a side. So it means add all sides. So on this first one over here, it's a square. And what do you know about a square? All sides are the same, which means this side has a length of x, just like the original one does, and so does this side, and so does this side. So when you add all the sides, technically you will be doing x plus x plus x plus x. Simplify, right? We always simplify whether they say or not. So that means the perimeter of this square would be 4x. Good? Notice there's no equal to sign, so it is an expression. Cool? And don't put one in. Some of you may be tempted to put an equal to sign here, saying x plus x, but don't do it. I'm telling you, don't do it, because as soon as you put an equal to sign, it's no longer an expression. We need an expression. Got it? Let's look at number 2. Number 2 is asking us to find the perimeter of the rectangle. They want us to write the expression. Well, what do you know about a rectangle? Yeah, not all sides are the same, but the opposite sides, the parallel sides, are the same. So if this side is x, the side opposite it, the other vertical side, would also be x, wouldn't it? And this horizontal side is x minus 5, which means the other horizontal side would also be x minus 5, wouldn't it? Okay, so perimeter again means add all the sides. So I'm going to take x plus x minus 5 plus x plus the other x minus 5. And some of you may be going, why did you write x minus 5 in parentheses? It represents a single side. That's it. Nothing more, nothing less. And since there's no distribution to do here, I can write it without the parentheses. And yes, I could have written it without the parentheses initially as well. No problem. And as always, simplify. So I'm going to add all my like terms. So in this case, I have 4x minus 10. That represents the algebraic expression for this rectangle. So if I knew what this side measured, I would actually know the entire perimeter by plugging it in. Cool? Okay, hang in there. Got a couple more examples. Okay, so let's look at this next problem. Directions are the same. They want us to write an algebraic expression, which means no equal to sign. So problem number 3 reads, the sum of 3 consecutive integers if the first integer is z. So here's the thing. You need to understand what consecutive integers are. Give me an example of 3 consecutive integers. I'm waiting. Good, I heard you. 3, 4, 5. Those are consecutive integers. Give me another example of 3 consecutive integers. I heard you. 19, 20, and 21. Good. Give me one more example. Yeah, 31, 32, 33. You get the hang of it? They come one right after the other, don't they? Now here's the thing. They taught us to count like that, didn't they? They said after 1 comes 2, and after 2 is 3, and after 3 is 4, etc., etc., etc. But what they never really told us is how we get from one integer to the next one, to the very next one, right? Okay, so think about it. Mathematically, how do you get from 3 to 4? How do you get from 19 to 20? How do you get from 32 to 33? Yeah, you add 1 every time, don't you? Okay, so hang in there. Let's talk here. So, the first consecutive integer, the second consecutive integer, and then the third consecutive integer. I know the first one is z. That's what they told me, correct? Okay, so how do I get from the first integer to the next one, the consecutive one? Good, we add 1. Just like to get from 3 to 4, you add 1. To get from 19 to 20, you add 1. So it's z plus 1, isn't it? Good. Now, how do I get from the second one to the third one? Yeah, you're supposed to add 1 again. To get from 4 to 5, I add 1. Agreed? So, just watch a second. So z plus 1 is the second integer, isn't it? So to get from the second to the third, we're supposed to what? Good. Add 1, which means the third consecutive integer looks like z plus 2. This is really what the third consecutive integer simplifies to. Are you with me? Okay, now they wanted the sum of these, right? So I'm going to take the first integer, add it to the second one, add it to the third one. And technically, I should put these all in parentheses, okay, to keep them like grouped together in my mind. This is the first one, added to the second one, added to the third one. Good? Okay, technically there's no distribution, so I can just add my like terms. What do you get? Good. 3z plus 3. This is the sum of 3 consecutive integers. So if I knew the first integer, I could plug it in and get the sum of all 3 of them. Cool? Okay, let's look at number 4. Number 4 is similar. It says the sum of 3 consecutive odd integers if the first one is a. All right, so we have the first consecutive integer, the second one, and I know some of you are going, do I need to write down what you're writing? You know, it's not a bad idea to do it. I highly suggest it because for us visual people, it keeps us on track so we understand what each of the variables are representing. Over here, I know z plus 1 is representing the second consecutive integer, correct? Okay, so back to problem 4. A is the first one, agreed? Okay, now before we go any further, in this case they talked about odd, consecutive odd integers. So give me 3 consecutive odd integers. Good, 3, 5, 7. Give me another set of consecutive odd integers. Good, 21, 23, 25. One more example. Good, 45, 47, 49. Good, so question. How do you get from one odd to the next odd? And don't tell me you skip one, because that's how they taught us to do it when we were kids. They said skip one. Instead of 3 to 4, you go 3 to 5. That's not it. Mathematically speaking, how do you go from 3 to 5? How do you go from 21 to 23? How do you go from 47 to 49? What do you do to get from one odd to the next? Good, I heard you guys. Add 2. So if my first one is A, my second one is, that's right, A plus 2. And you're like, that looks even. A is an, whoops, hold on, I didn't write something. First consecutive odd integer, second consecutive odd integer, third consecutive odd integer. I need to put this word odd in here to keep my brain on track. So sorry about that. Put that in your notes. I know A plus 2 looks even, but we specifically said A was the first consecutive odd integer. So if A is 27, then 27 plus 2 is, right, 29. So it's still odd. I don't care that I added 2. It's still odd because I add 2 to get from one odd to the next. Got it? Okay. Problem number 3 here, the third consecutive odd integer. Well, that means I have to take the second consecutive odd integer and do what? Yes, add 2, which means the third consecutive odd integer actually simplifies to a plus 4. Got it? Okay. Finally, I'm supposed to sum them. I'm supposed to add them. So my first odd integer added to the second consecutive odd integer added to the third consecutive odd integer. And yes, the parentheses just tell me those are 3 separate integers. No distribution to do, right? So you just add like terms, which means in this case you would get 3a plus 6. This represents the sum of 3 consecutive odd integers. And if I knew what the first odd integer was and I plugged it in here, I would get the sum of the first 3, or pardon me, I would get the sum of 3 consecutive integers. Cool? Hang in there. Got some more examples for us. Okay, let's look at problem number 5. Number 5 is asking us to find the total amount of money in cents of x nickels, x plus 3 dimes, and 2x quarters. And you're like, what? Think about it. Let me pose a question to you, okay? If you had 5 nickels, how many cents would you have? Good, 25 cents. How did you get it? Well, yeah, you know each nickel is worth 5 cents. And if you have 5 nickels, then you did the 5 nickels times the 5 cents, right? Okay. What happens if you had 6 quarters? How many cents would you have? Or how much money would you have? Right. You have 6 quarters. They're 25 cents each, which means you would have 150 cents, right? Or we say $1.50. But if they're asking cents, that would be 150 cents, right? How did you get it? Yeah, the 6 quarters times 25 cents each, right? Getting the picture? Okay, so let's look. We have got nickels, dimes, and quarters, right? And the number of each, well, they told us x nickels, correct? And they told us we had x plus 3 dimes, right? And then they said we had 2x quarters, yes? Okay, now here's a column that they didn't give us, but we know and we need to write. We need the value in cents of each of these. So a nickel is worth 5 cents. A dime is worth 10 cents. And a quarter, 25 cents. So total represents, again, the sum. Excellent. Which means to get the sum, you are going to add. Good. So let's think about this. We're going to add the nickels in cents plus the dimes in cents, right? Plus the quarters in cents. Agreed? Okay. So to get the amount of nickels, what did we say we were going to do? Or to get the value of the nickels, the total value of the nickels, we're going to take the number of nickels and multiply by that 5 cents, right? Added to the amount of dimes, which was x plus 3, multiplied by that 10 cents, right? And then added to the amount of quarters, multiplied by the 25 cents, right? Okay, now don't worry about the cents sign. It will come in at the end. Cool? Okay, so this is just 5x, isn't it? So we have this distribution. Good. 10x plus 30, and then 50x. And as always, we collect like terms, don't we? So I see 5x plus 10x. Good. 15x plus another 50x. Good. So this is 65x plus 30. And this is in cents. That is the total value of these many dimes and nickels in cents. And if I knew how many nickels I had, I could just plug it in and I'd find the total number of cents of these amount of coins. Good? Okay, let's look at problem number 6. Problem number 6 is asking me to express the total amount of fencing that's needed. So they've given us this picture, and I'm going to do a little erasing just so we have a little bit of space here and we can see it better. They've given me this picture of land that they're fencing off. And the key is it's subdivided equally. So now think about it. If it's subdivided equally, that means that if this is x, how much is this? Good, that's also x. And then how much is this? Good, that's also x. And this? Yep, also x. Wonderful. Now, if this width is 3x minus 15, then what's this one? Good, this one is also 3x minus 15. And this one? Good, also 3x minus 15. You getting the hang of what I'm going to ask you next? But I got one more, don't I? Yep, 3x minus 15. And they want me to find the total amount of fencing. Now, total means to add, right? So I can add all of this up. But I'm going to show this addition problem a little bit differently to help us out. I have got one dimension of x, right? And how many of those dimensions do I have? Good, I've got 4 of them. So couldn't I take x and multiply by 4? Okay. And then I've got this other dimension of 3x minus 15. And how many of those dimensions do I have? Yeah, I've got 1, 2, 3, 4, 5 of them. If I multiply by 5, wouldn't I have the total amount of that dimension? Good. And then I need to finally add them together because they want the total, right? So here is 4x plus, I've got a distribution problem, right? Good. That's 15x minus, stay off the calculators, good, 75. And as always, add like terms. So we have 19x minus 75, and whatever units it is, feet, meters, whatever. If I knew this one dimension, I could plug it in and find out the amount of fencing that I would need in order to subdivide this land. Cool? Okay, hang in there. Got some stories for us.